Hello, everybody, and welcome back, or hello for those who are coming in and joining us for the first time. My name is James. I'm one of the presenters today. Beside me here, I have William, and we have Calvin here. So this session is kind of a drop-in. We're just going to show you some hands-on activities that you can do from your own home. So there's a couple things that we wanted to kind of show and share with you. Feel free to use the Q&A if you have any questions or concerns. But just a quick reminder, if you are doing this at home, and please make sure that you have supervision and the proper safety gears on, okay?
All right. Hi, everyone. So if you're joining in from our earlier session, we talked a lot about acids and bases. And so we looked into how acids and bases reacted in terms with different indicators, but some things that you can do at home, and you can readily find acids and bases at home as well. Now, what I have here is probably familiar. If you like this on your fry, you might like this on your fries. So we've got some vinegar here. Vinegar is actually a type of acid. The chemical name for vinegar is acetic acid, and it's a kind of like a weak acid, but still an acid nonetheless. If we think about acids inside our house, we usually have other types as well. For example, we have citric acid, which is usually found in our fruits, so like lemons or oranges. And so acids usually give us that sour kind of taste. We also have bases at home as well. And one of the common things that you can find at home that is considered a base would be soap, right? And so, for example, you can have like bar soap that's usually made out of sodium hydroxide, or in other products as well. You have Windex, or in this case, you can also find that contains a base is baking soda. And so the chemical name for baking soda is sodium bicarbonate. And so we have our vinegar, which is the acetic acid, and then our baking soda or sodium bicarbonate. Now, the question is, what will happen when we try and mix these things together? Well, acid and bases usually form some type of reaction. The reaction really differs depending on what type of acid and what type of base you're combining. Sometimes it can create a very vigorous reaction. Or sometimes not, just kind of like a milder reaction. You don't really see a whole lot, but oftentimes you would see a lot of gas evolving, or a lot of heat or cold being generated. Now, of course, when we want to do any science experiments, we definitely need to put on some safety glasses just to protect our eyes, since we only have one pair of eyes. And of course, I have some gloves on already. And in this case, I also put on a lab coat, just so I can protect myself in case anything goes bad. Now, these are what we're going to show you right now are things that you can find easily at home, but always make sure you ask your parents before you try and experiment with any of this stuff, okay? Because it could be very dangerous, or it could create a lot of messy substances. So make sure you have adult supervision when you're playing around with this stuff. Now, what I have here is a cylinder. You can use any other type of container. This acid and base reaction, it might be something you commonly know as the Volcano reaction as part of science experiments. And so what I can do now is, first, I can add a little bit of the baking soda into a container here. I'm gonna squeeze some baking soda in here, right? So I'll fill my container with some baking soda. We can take a look at what baking soda looks like. It's a white powder. It's very fine white powder, as in it's very small, right? Not like as big as sand. And then, of course, our vinegar here is a liquid, right? So it's a liquid. And so what will happen here if I try and mix these two together? So part of science is to make some observations and also predictions as well. And so let's start off by pouring this vinegar into my cylinder here. To make things a little more interesting, let's make a green volcano in this case. So we'll add in some green food coloring. Give it a good mix. And so now we have our green vinegar. And let's see what happens when we mix this baking soda in there as well. So let's get a countdown going. We'll start from 3, 2, 1. Like that, like a volcano, it kind of erupts, right? It creates a lot of bubbles, a lot of gas. And we can see that it really smells vinegary here too. If you guys are here, you probably smell it as well. Now still have quite a lot of baking soda left. I can pour this in, the rest of it in. Hopefully that can start up the reaction again. So it's a chemical reaction that we're doing, not exactly science. Sorry, not exactly magic. There is some science to it. But you can see that even though if I pour in the rest of that baking soda, nothing really happens. Now the question is why? Well, what is happening here is that there is way too much baking soda as compared to the vinegar that we're trying to put in, right? And so in this case, this is what we call vinegar as a limiting reagent. And so just like if you were trying to make some cookies at home, or if say you have unlimited amounts of flour, unlimited amounts of water, but you only have 5 eggs, then you can only probably make around 10 cookies, right? Until you get more eggs, then you can start making more cookies. So in this case, if we want this reaction to continue on, we have to add in more vinegar. So the eggs was the limiting reagent there. In this case, this is the vinegar. So if I try to pour in some more vinegar, it should start the reaction back up again. And voila, there we go.
Okay, so if you guys want to do this at home, you can always feel free to do it at home. So all you need is just a regular bottle, something like a 500 milliliter bottle works. So in this, we can pour out some vinegar into our bottle. And you just need a little bit, not too much. Yeah, something like that. So not too much. And you can also grab a balloon, just a regular balloon you might find from the dollar store or anywhere else. And we can just put some baking soda into our balloon. So I'm just going to use a funnel here just to get that baking soda into here. You don't need too much. All right, we'll get that baking soda in there. So if you see, it's just some of the balloon is filled up with baking soda. And all we'll do is we'll take the opening of the balloon and stretch it over the opening of our bottle. Okay, and then whenever you're ready, you want to make sure you hold the opening of the bottle that's holding onto the balloon so it doesn't pop up. As you guys saw, the baking soda and vinegar reaction does create quite a bit of gas, carbon dioxide gas. So it's going to cause our balloon to expand, and we don't want that to pop off. So whenever you're ready, you're going to just flip the balloon over. We're going to give it a bit of a shake. And as you guys can see, our balloon will start inflating. So in this bottle, we're making carbon dioxide gas. It's rising up and inflating our balloon. And of course, if you add more vinegar, then we will be able to get more gas, as you guys saw with Calvin talking about limiting reagents. Okay, so we can remove this balloon. We'll take the balloon off. Okay.
Alrighty. So some other things that you can kind of do at home is what we call chromatography. Okay. So chromatography is a special way to or technique to separate molecules or compounds. And in this case, we're going to separate color. Okay, so all it really takes here is a plate of some sort. Doesn't have to be a disposable one. It could just be something that you can find at home. What's nice to use is a coffee filter. So it's just a standard coffee filter that you should be able to find at home. Tissue paper or paper towels kind of work too, but I like coffee filter because you can kind of let it sit there. And then you also need some water. So we have water readily available here, and you'll need some washable markers is preferred, but any type of markers will work fine, but the more colors you have, the better it is. Okay, so it's gonna go ahead and take some markers here, and what you want to do is be able to put some markings along the bottom, so you put dots. Okay, and you kind of want to go all the way around, so I'm just gonna go ahead and mark the bottom. But make sure you kind of leave about a centimeter or a finger kind of gap from the bottom. You don't want to put it all the way along the bottom, but just kind of go all the way around here. So I'm just going to go ahead and put other colors, and you want to mix in the colors with whatever you had before where you marked it. So right now I have black and blue on top of each other. Okay, so I'm going to go ahead and do a few more here. Maybe Calvin, if you want to do another one, we can show you what different combinations of colors that we can make. Okay, so let's go ahead and add some more. Okay, so just on the same spot, as you can see. Okay, so we got different colors all on the same spot. So we're all gonna do one here, just to show you that we can separate these colors all back out later. Okay, and we're just gonna be using water to help do the separation. Okay, so doesn't have to be every single dot, but as you can see, I have a mixture of colors here. Okay. And what you're gonna do is you're going to fill the plate with some water. And I think this will be a perfect thing that you can do for Mother's Day tomorrow. Okay, a little, maybe a gift from mom. We're gonna have some sort of beautiful color creation here. Okay. And what I'm gonna do is I'm gonna try and carefully stand this up in the plate and let it kind of soak in the water. You don't wanna push it down. You wanna let it soak from bottom up. Okay, so I'm gonna let the happen, and you can kind of watch very carefully here and see that the colors slowly start to kind of spread out. Okay, can you guys see those color separation here? You kind of see it here. It's the water is drawing up the different colors at different rates. Okay, so some of the molecules, we call them, right, will have different properties, whether it's the mass or the compound that it is. It will be drawn at different rates. So it's kind of like, you know, some people say, you know, heavier ones will go really quickly and sink down, right? Or lighter ones will take a while for it to sink, right? And then this is kind of the same idea, right? Things will run a little faster and the other one will run a little slower. So you can see a separation in terms of the color. Okay. So William or Calvin here has another one, and we're just gonna put it in there so you kind of see the difference here. So you just kind of let it run. And you can get a nice kind of spread of colors. If you do more colors all the way around, it's a little bit more obvious, but kind of see it there. So I kind of show you here. So once you are happy with how far it goes up, you can see when it dries up even, you're gonna get the difference in color in terms of the separation back out. And what I like to do afterwards is once it's dry, so maybe if I can do this properly, is kind of wrap it and fold it up in a nice way, okay? Okay, and you just do a bunch of these guys and you get a little pipe cleaner here, okay? And you attach it onto the bottom and you made yourself some flowers, okay? Perfect for Mother's Day that you guys can do for tomorrow. Okay.
Now, since we're talking about water, what we can also play around with is water inside a bag. So I just have here a container just to trap some of the water I'm gonna put in, and a Ziploc bag. Okay, so I'll pour some water into the Ziploc bag here, just fill it up. And I will try to zip this up. And so one of the cool things you can do with water inside a bag is to try and poke holes through it. So what I have here are just some skewers, right? And if I poke holes through this bag, what should happen is that we should not see any leaks, okay? So I can poke a whole bunch of skewers into here, right? I might even have some color crayons as well. So got some color crayons here. If I try to poke these through as well, all the water inside the bag should just stay. It should not leak out. Right? Look at that.
So you try and see how many you can do.
Yeah, so as a cool little trick, you can try and figure out how many pencils you can poke through without it bursting or without it actually leaking. In this case, I've got about 7 different things, 7 pokey things in here. And what we can see is that all the water stays inside because of something called surface tension, right? And so with the surface tension, the pencils and the skewers, they plug in the holes, and so they don't leak out. But what does happen though, if I start to pull out the pencils and pull out the skewers, we should start seeing water flow out. And so the water flows out in this case because now air has a chance to go inside the bag, and it's filling up the space. And so as I pull more and more pencils and skewers out, you should be able to see more and more water leaking out. So this is a pretty cool demonstration for surface tension.
Yes. So along the lines of surface tension, right here we just have our plate of water, and this time I'm going to have black pepper here. Okay, so black pepper, and we're just going to sprinkle it all over the plate. So you don't want too much, but enough that it somewhat covers a good 50% of the plate. A little bit more would be a little bit more obvious over the camera here. So let me just go ahead and do that. So just pepper, okay, is all you need, okay? And then we also have some Dawn soap. So Dawn soap works the best for most of our soapy substance here. And we're just gonna go ahead and add a little bit of Dawn soap onto a Q-tip. So if you have a little Q-tip, add a little bit of Dawn soap on there. So something really cool can happen, okay? And what you're gonna do is you're just gonna watch very carefully. I am going to touch that surface. So if I was to just use a regular kind of tip and I touch it, nothing really happens. But once I dropped in some of that soap in here, right? Notice that it kind of pushed it all away. So let's try that again here. Okay, I had a drop of soap go down. So let's try that again. Okay, so go ahead. I'm gonna add the drop here. So let's kind of touch it. And notice that it pushes everything away, right? So we're gonna do the same thing, but this time we're gonna add some milk. So we bought some milk this morning here. Okay. And instead of pepper, we're gonna use food coloring. Okay, so just get a mixture of different food coloring here. And we're just gonna drop it in the same area. So all you need is just one drop in the center. A little too much there, maybe.
All right, so let's try that again here. So we've got a plate and some milk. And we're gonna add little pieces of one drop of food coloring to the center of the milk. Okay. We'll add in one last color here. And
then what we'll do is we'll grab some kind of cotton swab or a Q-tip, something that looks like this. And all you'll do is you'll take some Dawn soap or any dish soap, and we'll just add a little bit of that soap onto our cotton swab, just like that. And then once you're ready, what we'll do is we'll touch the tip of our cotton swab on the center of our plate. Just like that. And if you see, you'll be able to see that the food coloring will spread all around to the edges. And as you guys can see, it's still moving around as we touch the center. So just like that, something really cool you can do with just milk, some dish soap, food coloring, and a cotton swab.
Our last one here is just something that you can do and talk about density and learn about density. So it'd be nice to just have, 4 different cups, okay? And you're gonna add about the same amount of water to each one. Okay, so we're gonna grab some water. Okay, and we're gonna add some water to each one, but in addition to water, we're also going to add some sugar. Okay. Now, the amount of sugar will need to be varied. Okay. So usually I like to be consistent and I get a spoon. So it could be a big spoon, small spoon, whatever works. You may have to test it out. So we're going to try and test this out ourselves too. So I'm going to go ahead and add one here.
One to our cup number one. And then we're gonna add 2 scoops to our cup number 2. 3 scoops to our cup number 3. And finally, we're going to add 4 scoops to cup number 4. So we have 1 scoop of sugar, 2 scoops of sugar, 3 scoops of sugar, and then 4 scoops of sugar. And then we can have a cup as well with no sugar.
Just so we're somewhat consistent with the amount of water, I just have another cup. You can use little small Dixie cups as you wish as well. So I'm just going to add equal amounts, approximately equal amounts to each one. And then you can use a spoon to kind of stir it up, or a stick, or a chopsticks, anything along that lines. So sometimes using hot water will also help. The hot water will kind of help it dissolve a little bit better. So depending on the amount that you have, maybe a little bit more difficult to kind of dissolve. So if you add a little bit more hot water to it, it might help with everything. So I'm just gonna go ahead and add a little bit more water to each cup. So maybe I'll do a half cup this time. Okay, so just to be somewhat consistent. And then we're gonna do food coloring to each one. Now, it doesn't have to be a rainbow in any way. Okay, so just do it in a mixed order would be nice. And then we can mix colors. So if you only have like a blue and yellow and you want a green, you can go ahead and mix that together. Okay, so we're gonna try some variation. We can leave, say number 2, colorless, if we want to keep it colorless.
So if we look at all our different cups, we can take a prediction as to we added sugar into each cup with water. So which cups do you think would be the most dense, and which cup do you feel like would be the least dense? So what we can do is we can start with pouring in the most dense liquid that we have. So pour a little bit of this in.
So you want to kind of pour it through the sides if you can. And ideally, if you have it very dense, it would stay at the bottom.
Then next, we're going to move on to the next most dense. So we gently pour it down the side.
So if we mix up the order and see what happens here. Okay, you slowly see the different phases here. I know it might be a little hard to see on the screen.
So just by using the same ingredients, water and sugar, by changing the amount of sugar we have, we can actually get separation of the different colors from the different cups. So we get different layers from each of the different cups.
Start with blue.
So let's do that again if we start with blue instead and see what happens.
So technically it would mix together, right? So we would expect it to mix. So we go start with maybe yellow, maybe perhaps. We start with yellow and let's switch to blue and let's see what happens there first.
So you want to be really careful to add it in slowly so that we don't mix them all together. So right now we have these two layers. You'll be able to see yellow on the bottom and then blue on the top.
So the next one here, we're gonna add the red. If you glide it in slowly, it should sink all the way towards the bottom. So notice that it goes towards the bottom rather than being it up on the top. So you're actually adding towards the bottom. Obviously, yes, you will get a light kind of mixing occurring, but you can see that the red has swapped down towards the bottom. Okay. All right. So that's about it here for today. So, I mean, we're open here for questions if you guys have, but that's kind of all the hands-on activities that you guys can kind of do at home. And again, make sure you have supervision if you guys are trying this out. We do have all these recorded on the Science Outreach website. You should be able to find a few of these videos available online with more instructions.